Okay, so here we begin with the last problem of recitation 6. Here we are supposed to design a rise function for a follower from A to E. We can use uniform and parabolic functions. So for BCD, uh, speed for the follower is constant. So that means the second derivative is constant, and that means follower rise function for the follower is linear from B to D. So this means that this is linear from A to B. We are having a constant acceleration. That means parabolic function has constant second derivative, and that means I have a parabolic function from A to B. D to E has constant deceleration, which is similar as A to B. So over here as well, I do have a parabolic rise function. So now we know that a rise function consists two parabolic and one linear. So from A to B parabolic, linear, and parabolic consecutively, respectively. So this means that, and once we have figured this out, we just have to follow the process. We have to write the function and we have to write the boundary conditions. So let me start for A to B, and I have a parabolic function that is y1 theta is equal to a naught plus a1 theta plus a2 theta square. Now let me write the boundary conditions. Y1 of 0 is 0, which is given. Y1 of 30 degree, that is pi by 6, that is given. That is not given. And y1 dash of 0 is 0. We are starting from rest. However, that is not given. So we have to assume that we are starting from rest. And that means y dash of 0 is equal to 0. And y dash of pi by 6 is kind of given, but we need to figure it out. So we have been given constant speed of 12.12 inch per second for follower, and that is in time. So y dash of t is equal to y dot t is equal to y dash of theta into omega. So omega is given as, so y dot t is 12 and y dash theta will be into omega. So omega is given as 150, that is over here. So that will be 150 into 2 pi by 60, which is 5, and that means y dash of theta is equal to 12 upon 5 pi, and that is my velocity for starting at B. So this is going to be the value over here, 12 by 5 pi. So velocity at B has to be same. For linear part, velocity is given as 12 by 5 pi. So for parabola as well, velocity has to be 12 by 5 pi to ensure the continuity in position, ensure the continuity in velocity. So we have to ensure that position and velocity are continuous at point B, D, and E, which has been given. Position and velocity has to be continuous at these 3 points, B, D, and E. So continuity, we are using continuity in velocity at B, we are getting y dash of pi by c is equal to 12 by 5 pi. So we do have boundary conditions right now. We do have 3 boundary conditions and 1 equation. So if I go ahead and start substituting, so y dash of theta is equal to a1 plus 2a2 and theta. Now if I go ahead and start substituting my values, I'll get y dash of 0 is equal to 2, a1 is equal to 0 from this, from the one of the boundary condition, and y1 of 0 is equal to a naught, which is also 0, and y dash of Okay, so y dash of pi by 6, that will be 2 into a2 into pi by 6, and that is equal to 12 by 5 pi. So value of a2 will be 36 by 5 pi square. So my y1 theta will be 36 by 5 pi square into theta square. That is my rise function from a to b. Now let's go ahead and write the rise function for part b, c, and d. So that is linear. So y2 of theta will be b1 plus b2 into theta. Now let's write the boundary conditions. So y2 of pi by 6 will be equal to y1 of pi by 6, and that comes from the continuity in position. Y2 into, so this point is 5 pi by 6, where we will, where linear rise function will meet the parabolic rise function. So y2 of pi by 6 has to be y3 of, that is 5 pi by 6, y3 of 5 pi by 6. That is actually unknown, so we'll leave it right there. And y2 of pi by 6, y2 dash of pi by 6, that is 12 by 5 pi, which we calculated just now. And y2 dash of 5 pi by 6 is also 12 by 5 pi. So we are going to use these two equations to calculate our unknowns, because we just have two unknowns, and that is b0 and b1. So y2 of, let's start with velocity first. Y dash of 12, y dash of pi by 6 is equal to b1, and that is 12 upon 5 pi. That is the value of b1. Now we can calculate the value of b2, value of b0, y2 of pi by 6, that is equal to 5 1 of pi by 6, and that is equal to 36 upon 5 pi square from the previous function into theta square. So that is 5 by 6 into pi by 6. So that is equal to 1 upon 5. And b naught plus 12 by 5 pi into pi by 6 to pi. So b naught is equal to 1 by 5 minus 2 by 5, and that is minus 1 by 5. That means y2 of theta will be equal to minus 1 upon 5 plus 12 by 5 pi into theta. Now let's write the third parabolic rise function, and that will be from d to e. Y3 theta will be c0 plus c1 theta and c2 theta square. Now let's write the boundary conditions. So y3 of 5 pi by 6 is equal to y2 of 5 pi by 6, y3 of 5 pi is gonna be equal to y4 of pi, and that is 2 inches over here. Y3 dash of 5 pi by 6 is equal to the constant value of velocity in linear function, and that was equal to 12 upon 5 pi. And y3 dash of pi, that is going to be 0, because velocity at e2f is 0, as my follower is going to dwell on e2f. So let's go ahead and start with the velocity, because that will give us two unknowns and two equations. So y3 dash theta is equal to c1 plus 2c2 theta, and I'm going to start replacing my boundary conditions, and this will give me c1 plus 2c2 into 5 pi by 6 is equal to 12 upon 5 pi, c1 plus, and y3 dash of pi is equal to c1 plus 2c2 pi is equal to 0. And over here I have 3. Let me keep this. Now I can solve this equation and I can find the answer, and that will be 12 upon 5 pi and 3. This means that value of C2 is equal to minus 36 upon 5 pi square. Now similarly we can calculate the value of C1 from the previous equation. 2 pi is equal to 0 and C1 is equal to minus 2C2 and pi. Minus 2 into 36 upon 5 pi square into pi, and this will be equal to 72 upon 5 pi, and that is my C1. Now let's use this condition. So y3 of pi is equal to c0 plus c1 pi plus c2 pi square, and that is 2. So c0 plus 72 by 5 pi into pi plus minus 36 upon 5 pi square into pi square is equal to 2. That is c0 minus 36 upon 5 is equal to 2, which eventually give me as 2 minus 36 by 5 and minus 26 upon 5. So value of c0 is equal to minus 26 by 5. So value of y2, so expression for y2 will look like this. So we missed one boundary condition. Now we can verify that too, and that is y3 of 5 pi by 6 is equal to y2 of 5 pi by 6. And let me check the value of y2. So that is minus 1 by 5 plus 12 upon 5 pi into 5 pi by 6. So that is 9 by 5. So same value I should get from value expression of y2 as well, expression of y3 also. So let's calculate the value of y3 of 5 pi by 6. Minus 26 by 5 plus 72 by 5 pi into 5 pi by 6 minus 36 upon 5 pi square and 25 pi square by 36. Minus 26 plus 12 minus 5, so that is 7 minus 26 upon 5, and this is 35 minus 26 by 5. So yes, it is equal to 9 by 5, and that's what we were expecting from here. So these two values are equal, you can see. So here we have verified that my position and velocity both of them are continuous at points B, D, and E based on our boundary conditions. So here is the function for y1 36 by 5 pi square theta square, y2 minus 1 by 5 plus 12 by 5 pi into theta, and y3 theta is minus 26 by 5 plus 72 by 5 pi into theta minus 36 by 5 pi square into theta square.